module, you will learn about Newton's first law of motion. Newton's laws of motion have their roots in Galileo's law of inertia. In fact, Newton's first law of motion is almost the same as Galileo's law of inertia. Newton's first law of motion states that every object continues to be in its state of rest or of uniform motion in a straight line unless compelled by some external force to act otherwise. If you observe, there is no mention of acceleration in Newton's first law of motion. This is because when a body is in a state of rest, it has no acceleration. Similarly, a body in uniform motion in a straight line does not accelerate. Based on these facts, we can express Newton's first law of motion in two more very useful forms. 1. If the net external force on a body is 0, its acceleration is 0 and vice versa. 2. A body accelerates only when a net external force acts on it. These two forms of the law are extensively used while solving problems in kinetics. Let us apply what you have learnt in this module so far to analyze some day-to-day events. When you are standing on firm horizontal ground, what are the external forces acting on you? What is the net external force acting on you? Let us try to answer the first question. The first thing that comes to mind is your own weight, say 500 Newton. This force acts vertically downwards. Is there any other external force acting on you? You can now apply the knowledge from this module to analyze these situations. You are at rest. That means your acceleration is 0. Since you have already identified one external force acting on you, that is, your weight acting vertically downwards, there must be at least one more force which is equal but opposite to your weight, so that the net external force acting on you is 0. This force is the normal reaction between your feet and the surface of the ground. While attempting to answer the first question, you have also answered the second question. The answer to the second question is net external force acting on you is 0. Let's consider another situation. What are the external forces acting on you if you are standing in quicksand instead of on firm ground? Your weight is the same. But what about the normal reaction? It can't be equal to 500 Newton. It is definitely less than 500 Newton. How did you come to this conclusion? Simple. You are sinking into the quicksand. That means you have an acceleration vertically downwards, which implies that there is a net external force acting vertically downward. Let's take an example from a physics laboratory. An iron cube is placed on a glass sheet, which is fixed to a wooden plank. This wooden plank is hinged to a horizontal surface. The wooden plank is slowly tilted until the iron cube is about to slide down on its own. That is, without any external force being applied to it. This position of the inclined plane is known as position at impending motion. Theta is the angle between the inclined plane and the horizontal surface. We now have to identify the external forces acting on the iron cube. W Newton is the weight of the iron cube acting vertically downward. On resolving this force, W along with x and y directions. We get Wx is equal to W sin theta and Wy is equal to W cos theta. As W and theta are known to us, Wx and Wy can be calculated. At the point of impending motion, the iron cube has the tendency to slide down, but is prevented by the frictional force, F, between the glass surface and the surface of the iron cube. How do you find the magnitude of this frictional force, F? There is no motion of the iron cube in the x direction. That is, the iron cube is at rest as far as the x direction is concerned. This implies the net force in the x direction is 0. Net force along x is equal to F minus W sin theta is equal to 0. Therefore, F is equal to W sin theta. The iron cube is not going into the glass sheet, which implies that the iron cube is at rest as far as the y direction is concerned. Hence, the net force in the y direction should also be 0. N is the normal reaction of the glass sheet on the iron cube. We can now write net force is equal to N minus W cos theta, which is equal to 0, or N is equal to W cos theta. We have used Newton's first law of motion to find the value of F and N, which were not known to us. You have now reached the end of this module. In this module, you learned that Newton's first law of motion states every object continues to be in its state of rest or of uniform motion in a straight line, unless compelled by some external force to act otherwise. If the net external force on a body is 0, its acceleration is 0 and vice versa. A body accelerates only when a net external force acts on it.